Some more review questions, but this time I want to focus our attention on parallelograms, and you can bet there'll be some questions on your homework and also some questions on the quiz about parallelograms and the properties, not just of a parallelogram in general, that we'll have on there, but also specific types like rectangle, rhombus, square. Okay, so let's just review some of the basic general parallelogram properties. First, the opposite sides of a parallelogram are parallel. That's what we mean when we see these lines opposite each other and the number of arrows on the lines. Next, they are congruent. That's what the hash marks mean, you know that. Opposite angles are congruent. So the far corners are opposite each other, so they're going to be congruent. That's why the 1 mark and the 1 mark, and then the 2 marks and the 2 marks. The diagonals of a parallelogram bisect each other, okay? And then the consecutive angles of a parallelogram are supplementary. In other words, this 1 mark here with the 2 mark here, if you add them up, you get 180 out of the deal. So those are your general parallelogram properties. Now to that, you add a rectangle, which has the fact that there are 4 right angles and the congruent diagonals. A rhombus, which has perpendicular diagonals, not congruent, perpendicular. Those diagonals bisect the vertices, and all 4 sides are equal. And then finally, with a square, you have everything. You got the right angles in the corners, you got the congruent diagonals, you've got diagonals bisecting vertices, you've got all 4 sides equal, and perpendicular diagonals. All of those properties for a parallelogram come off of the idea of 2 parallel lines cut by a transversal, and then just taking those properties, except for, of course, the diagonals bisecting each other, that's in and of itself, and applying them to what we already know about parallel lines. Speaking of diagonals bisecting each other, find x, find HO, and find HJ. Go ahead. Okay, so diagonals bisect each other, so these are equal, which makes 2x plus 17 equal to x plus 40. Subtracting the x, I get x and 17 make 40. Subtracting the 17, x is 23. That is the answer to part 1. Part 2 says HO. HO is x plus 40, so that would be 23 plus 40. Gives you a whopping total of 63. And then it wants HJ, which is the whole piece. And we can do that 2 ways. I can also plug in the 23 for x here and do 2 times 23 is 46 plus 17 is 63. Or I could have just doubled the 63 and come up with 126. Either way, the length of HJ is 126. And we've already talked about how much I appreciate whichever direction you come at this from, you arrive at the same solution. Okay, next up. Find all the other angles. Go ahead. Well, we know the opposite angles are congruent, so that makes angle Y 133. And we know consecutive angles like X and Y or X and B on 133 are going to add up to 180. So that makes this, oh, I don't know why I put that there. It makes it 47. This was from a previous slide. Ignore what's up top. 133 and 47 add up to 180. And then Z is opposite X, so that's also 47. Okay, and again, emphasizing that this is just a specific application of 2 parallel lines cut by a transversal and how consecutive interior angles add up to 180 degrees. Find X. Well, we just said a second ago that 2 consecutive angles add up to 180. So the x plus the 4x has to be 180. Same side, same operation. Add them up, you get 5x is 180. Dividing by 5, and you get x is 36. It only said to find x, so we can stop there. We don't need to go further and find either the measure of A or B, or C or D for that matter. Okay, so the distance from A to E is 5. That much you're given in the problem. Mark says that AC is 10. Do you agree with him? Why or why not? Show your work and refer to the properties of a parallelogram that support your argument. Oh yeah, I definitely agree with Mark. The reason is because the diagonals bisect each other. So if A to E is 5, then E to C is also 5, and the whole length from A to C is 10. Okay, this is a rectangle. What do you know about the vertices of a rectangle? 90 degrees. So that means that the 8x plus 1 and the 4x minus 19 have to add up to 90 degrees. Go ahead. Okay, so Oh, excuse my yawn there. It's about 8:30 on Friday night, January the 21st, as I record this, so that you know how many weeks in advance I work. 8x and 4x make 12x. 1 and negative 19 make negative 18 equals 90. 12x minus 18 is 90. Adding 18 to both sides, 12x is 108. Dividing by 12, and I get x is 9. It only said to find x, so I am done. This is rhombus ABCD. Remember the properties of a rhombus? Find y. Go ahead. Okay, in a rhombus, all four sides are equal. So therefore, 5y minus 6 is going to equal 2y plus 3. Subtracting the 2y, 3y minus 6 is 3. Adding the 6, 3y is 9. Dividing, and y is 3. Doesn't ask for y. Oh, what are they asking for, as Mr. Breeze would say? 2y plus, AB. AB is across from CD, but it's a rhombus, so they're all equal. It's the same as AD. It doesn't make a difference. So 2 times 3 is 6, plus 3 is 9. And next up, another rhombus. ABCD is a rhombus. Now remember, with a rhombus, we got a whole lot of special things going on here with angles. The diagonals are perpendicular to each other. So in here, we have 4 right angles. Next, a diagonal bisects the vertices. So at a vertex, each half cut by the diagonal are going to be equal to each other. So ABC is 4x minus 2. DBX is 3x minus 3. Figure out the relationship involved. Find x. Okay, so what we see here is that angle DBC is half of angle ABC. So if I double the DBC, I get ABC. Okay? Again, if you look at the diagram from D to B to C, that is 1/2 of from A to B to C. And the only reason I'm sure it's a half is that this is a rhombus. Okay? So I'm going to double DBC. That gives me 2 times 3x minus 3, and I will equal 4x minus 2. So, distributing the 2, 6x minus 6 is 4x minus 2. Opposite side, opposite operation. 2x minus 6, negative 2. Add them up. 2x is 4, and x is 2. That's what they wanted. I'm all done. Let's just hit up those parallelogram properties again. Just to have you remember it by looking at it. Opposite sides of a parallelogram are parallel. Opposite sides of a parallelogram are congruent. Opposite angles of a parallelogram are congruent. The diagonals of a parallelogram bisect each other. And the consecutive angles, the ones in a row, like these guys down here, they are supplementary. So let me ask you a question now. This is important. Give me 2 properties that a rhombus has going for it that are special to it and are not properties of a parallelogram. Well, I can think of 3. Choose any 2 of the 3. All 4 sides are equal. Diagonals are perpendicular. Diagonals bisect the vertices. What are the 2 properties that make a rectangle special? Right angles in the vertices. Diagonals are congruent. What are the properties that make a square special? Absolutely everything. You got, first off, rhombus, rectangle, square, they all got the parallelogram properties. But what the square also gets is it gets the 4 right angles in the vertices. It gets the diagonals perpendicular. It gets the diagonals are congruent. It gets that the diagonals bisect the vertices. And it also gets that all 4 sides are the same. All right, so that's our review of parallelograms. Now let's get going on some more work with proving triangles congruent and CPCTC.